So, if you've ever built a retrieval augmented generation app, a RAG app, you've probably felt the pain, right? You get these vague answers, sometimes totally incorrect information, or just garbage. And you start tweaking your prompts, maybe you swap out your models. But what if the real problem is hiding somewhere you're not even looking? Well, that's exactly what we're going to dig into. This quote right here, it just hits the nail on the head. The most common reason these RAG systems break down isn't the fancy AI model. It's a really fundamental step in your data prep that almost everyone overlooks: chunking. So let's frame this the right way from the start. We're going to see why the root cause of all those frustratingly bad answers is actually in how we prepare our documents, long before the LLM even sees them. Okay, quick refresher for everyone. RAG is this incredibly powerful technique. You take your own documents, you break them up, and when a user asks a question, the system grabs the most relevant little snippets to give the LLM the exact context it needs to give a fantastic answer. And it's that middle part, how we prepare the documents for retrieval, that makes all the difference. And this, right here, is where things usually go wrong. Pretty much every getting started tutorial out there tells you to do this. Just take your document and chop it up into these neat, fixed-size pieces, say 512 tokens. I mean, it seems logical, it's super easy to code, and it kind of works until it spectacularly doesn't. The core problem is actually beautifully simple. Ideas don't care about your character counts. You see, a document isn't just a long string of words. It's a carefully structured collection of ideas, paragraphs, and sections. And using a fixed-size chunker just completely, and I mean completely, ignores all of that. This slide shows the damage perfectly. On the left, you've got fixed chunking, which is like using a blunt axe. It just hacks through the text right in the middle of a sentence, or it splits a headline away from the paragraph it's describing. The context is just destroyed. But on the right, you have semantic chunking. That's like using a surgeon's scalpel. It carefully preserves whole thoughts and keeps everything connected. And this leads to a really bad consequence. When your system fetches one of these broken pieces, what are you actually giving the LLM? It's not a complete thought. It's a fragment. So the model, trying to be helpful, is forced to guess, to fill in the blanks, and that's when it starts to hallucinate. So we really have to shift how we think about this. Before we start blaming the model, we have to recognize this for what it is. This is a data pipeline problem, plain and simple. Garbage in, garbage out. So what's the fix? Well, it's this really elegant concept called semantic chunking. The whole idea is simple. Instead of splitting by some random number of characters, we're going to split based on the meaning and the structure of the text itself. And this whole approach is built on three really core principles. First, respect paragraphs. They are complete units of thought, so don't ever slice them in half. Second, you have to keep headers attached to their content. A title like authentication flow is totally useless if it's floating around by itself. And third, uses small overlap between your chunks. This is a subtle but super powerful way to make sure that ideas that cross a boundary are still connected. And the best part is you don't have to build all this from scratch. The big libraries like LangChain and LlamaIndex already have tools that are perfect for this. You can use a markdown splitter that understands headers, or a recursive splitter that cleverly works its way down from paragraphs to sentences, all while letting you add that crucial overlap. Okay, talk is cheap, so let's actually see this in action. I've taken a technical document and I've processed it two different ways, once with that old fixed chunking method, and then again with our new semantic approach. We're going to ask the exact same question to both and just watch what happens. Whoa, look at this. With fixed chunking, the context that it retrieved starts right in the middle of a sentence. It's just a fragment. So, unsurprisingly, the LLM gives an answer that's, well, it's correct, but it's incredibly vague. The system uses tokens for access. Yeah, not very helpful, is it? Now look at the result from semantic chunking. The retrieved context is a complete thought, and it includes the section header. So the LLM's answer isn't just precise, it even cites its source from the document, according to Section 3.1 on authentication flow. Now this is the quality we're looking for. Just let that sink in for a second. We use the exact same language model, the same embeddings, the same query. The only thing that changed was our data preparation. That massive jump in answer quality came from just one single change. That's how powerful getting your chunking right is. So as we wrap this up, I want you to think about leverage. In any complex system, there are a few things you can change that will have a huge impact. And for RAG, fixing your chunking, that is your highest leverage move. This is it.
If your RAG pipeline is not performing well, this should be the absolute #1 thing you investigate. It's going to give you more bang for your buck than pretty much any other tweak you could possibly make.
So here's the key takeaway, the bottom line. Before you spend hours and hours prompt engineering or go down the rabbit hole of testing a dozen different embedding models, just stop. Go all the way back to the beginning of your pipeline and fix your chunking first.
And I'll leave you with this question. Think of it as a simple gut check for any RAG project you're working on. The next time you're staring at a bad output and feeling frustrated, don't immediately blame the model. Just ask yourself, have I actually fixed my data?